trying to make a scratch or any marking on the material, if that material is resisting for any marking on the material, it is said to be hard. So basically, there are three types of hardness by which we can test it. They are scratch hardness, and by rebound, and by the indentation. So scratch is directly scratching on the material. In the case of rebound, we are applying a dynamic load or a moving load so that an impact is made on the surface of the material. And the indentation is the static way, that is just applying a force to a material in a very static way. That is, we are not applying any dynamic forces. So in this lab, we will learn the three indentation hardness process or test, which includes the Rockwell hardness test, Brinell hardness test, and the Vickers hardness test. So one thing to notice is that the hardness is a relative parameter. The hardness doesn't have any unit. So these are the various scales in a very basic way: the Rockwell scale, the Brinell scale, and the Vickers scale for measuring the hardness. For these three different experiments, there will be a slightly varying procedure to find the hardness on the corresponding scale. So we'll go to the first experiment, Rockwell hardness test. In the Rockwell hardness test, the aim is to determine the Rockwell hardness number on B and C scales for a given metallic specimen. Okay, so here the first thing is B and C scale. So generally we can classify the material into soft material and hard material. So if we are using a soft material to test, we will go for a B scale, and hard material we will go for C scale. Test setup includes the Rockwell hardness testing machine, the very important one, and the indenters. So these are used to make some marking on the material. So we have two scales I told. So for the B test, we are using a steel ball indenter of diameter 1/16 inch. So this is for the soft material, and the Rockwell C is for the hard material, and for that we use the Rockwell diamond cone of vertex angle 120 degree and tip radius of 0.2 mm. So you know the diamond is very hard material, so you need diamond for testing the hardness of hard materials. So this is the image of an Rockwell hardness testing machine. So on the left hand side, you can see the machine with a dial and a platform. So we will place the material on this platform, and then we will rotate this lever, and so that the platform will move upwards and it will be tight. After the tightness is obtained between the sample, we will apply a static load to measure the hardness in Rockwell testing machine. It's a very basic way, and there is a procedure involved. So this is a close view of the platform. On the right hand side, you can see two more important points, like one is the lever arrangement and one is the load selector. So this lever arrangement is used to lock and unlock the load, and this dial or this selector is used to give the proper loading to the sample. So we are giving different loading for the soft as well as the hard material. So for soft material, we will use the Rockwell B scale and 100 kilogram force, and for hard material, we will use the C scale and 150 kilogram force. So you have seen here for the Rockwell C scale. Proceeding on, these are the indenters we discussed in the second slide. One is a steel ball indenter on the left side is for the soft material, and the right one is the diamond hard material. So these indenters are placed at this point based on the requirement, that is based on the material, type of material to be tested. So for soft you will use this steel ball indenter, and for hard material you will use for this diamond material. And this is the dial which directly gives you the Rockwell hardness number. So this is not that much clear, but I just tell you the different dials in this one. So you can see an inner dial here. So this inner dial, you can see a red spot. So after placing the specimen on the platform, we will raise this platform, and the initial load of say 150 is applied, and at the initial loading stage, the inner dial, this small dial, should be in line with this red spot. So this is the initial step. This initially this small dial should be in line with the red line. Then after ensuring that, you will release the lever so that the load is applied on the sample, and you have three scales basically. One is this red scale having this red markings, and beyond that you have a black scale, and the last scale is not required for you. This red scale is the indication of the B scale, that is for soft materials, and this black scale is for the hard material, C scale. So these are the type of specimens we will use in our lab. Normally we will use a cylindrical specimen. So if it is not available, we can go for a bar type material. So you can see here the soft material brass and the hard material mild steel. So this was telling regarding the load selection for different type of material. Out of this listed 5 materials, the brass, gunmetal and aluminum are designated as the soft materials. So we will go for the Rockwell B scale, that is that red one, red dial for measurements, and we will give a load of 100 kilogram force. And for the cast iron and the mild steel, we will give 150 kilogram force for the test. So this will be the readings you will take from the dial. I have listed here aluminum, brass and mild steel, and again mild steel. The reason is that the here the mild steel is taken as both soft material and hard material. All the ball indenters, steel indenters corresponds to the soft material, and the cone indenters, diamond cone indenters, it corresponds to the hard material. So the repetition is due to the said reason. So for aluminum, using the ball indenter, we are using 100, 100, 100 as I told, and we are used the B scale, and these are the 3 readings directly from the dial. Similarly for brass and the mild steel, and as a hard material, the value will correspond to the C scale, HRC. It is hardness Rockwell C scale. HRB is hardness Rockwell B scale. So in the C scale, the mild steel, the 3 values are taken, take the average, and similarly for the tool steel. So these are the different hardness value from the Rockwell test. Okay, I will just show you a video. Just a minute. This is actually Vickers. We were discussing the Rockwell test. Yeah. So are you able to hear the voice also? Can anyone reply?
Sir, clear അല്ലേ sir? Echo പോലെയുണ്ട്.
Clear അല്ല sir. Clear അല്ല.
There is a sound disturbance in the video itself. Is it like audible at least to the basic quality? And I played. Hope it is. So I'll just magnify it. So we're telling. എന്താണ് പറഞ്ഞോളൂ.
ജിഗിൽ ഓഡിയോ മ്യൂട്ട് ചെയ്തോളൂ, അത് ക്ലിയർ അല്ല വീഡിയോയിലുള്ളത്. ജിഗിൽ പറഞ്ഞാൽ മതി.
ശരി മാം. Okay, so this is the corresponding machine parameters, like the hard materials will go for 150 kilogram force, soft materials 100 kilogram force, and we will use the diamond cone indenter for the hard materials and steel ball for the soft material. So I'm just make it fast forward.
This flat and
this is the Rockwell testing apparatus. So these were the dials I was telling about, the inner dial for the initial loading arrangement, so that it should be in the in line with this red dot, and the red one is for measuring the soft materials, and the black one is for the hard materials.
In which there's a inner part, there is a small dial is also there, and outside that one small dial that is provided inside. Fixing the specimen, making that point, then you have to see the portion. Simply by rotating that one, you can see 150, then 100, then.
This regarding the change or load selectors.
These are the
based on the material type.
So if it is kept like this, that is with the load to be applied is 100 kilograms. And then this is the
arrangement for releasing and locking the load.
Here, this is the lever that is used for applying this.
So these are the two indenters. One is a steel ball indenter, and the next one is the diamond cone indenter.
First one is a ball indenter. This is the into the tip of this attachment. So this is a ball.
So by indenter, you can mean like there is a very small ball-like or like a cone-like arrangement at the tip of this attachment, so that then impression is made on the material.
Indenter, ball indenter, and the other one is a cone indenter.
And this is called as the indenter, and the marking on the material is called as indentation.
You can see it's a single piece. Just like
so you can watch the video in detail for detailed information. I'm just going to fast forward.
Piece of a diamond. Now the specimen will be kept.
So here the laptop arranged the attachment or the indenter on the top of this Rockwell testing machine, and he placed the material to be tested.
Bottom platform. Now by rotating the
by rotating this, we can raise this platform so that it is in touch with the indenter.
The top of the specimen will touch the indenter. Now raise the platform until the specimen.
So some additional information. If you are using the material for one time, there will be a indentation. There is a marking on the surface. So suppose you are testing it for the second time, you should place the indenter at a point of like 2.5 times the diameter distance from the previous marking. That is, two indentation should not be near, because there will be a interaction effect.
Touches the bottom of the indenter, and if you further rotate the base, you can see that one is a dial will.
Yeah, so initially they are trying to make it in line with the red one.
Will coincide with the zero reading of the.
Yeah, now it is in red line, so the initial load is applied.
Small dial indenter will coincide with the red mark. As a small needle should coincide with the red mark. Exactly.
So this focuses only on this inner circle. We don't want to concentrate on the zero scale. Once you get in contact with this red dot, you can arrange this dial and make it a zero for starting the taking the measurements. So now the initial load is applied. They are checking.
We are going to selecting 100. You have to fix the clockwise dial, clockwise direction, and the dial is moving. And keep the loading.
It seems the dial is moving for the measurement. So as this is a soft material,
Lever is brought to the initial position. Then you see
we'll
the
use
reading
the
on the
red scale for measurement.
soft material. So the reading on the red dial is to be taken. So now it is 47.
So it's approximately like B40 is this value, B50 this value. So you can count plus 1, 41, 42, 43 will be the values for the soft
hardness
soft
of
material.
48.
And similarly, the experiment is
Not seen on the surface.
yeah. This is about the indentation. You can see the markings on the surface. So suppose if the brass material is very hard, then the depth of indentation will be very less. So this is a measurement with hardness, and as I told, you should not make the two indentions very close. It should be minimum 2.5 times the depth of this indentation for a clear correct value.
Repeated number of experiments. So when you keep the specimen under the indenter, you have to select a place where there is already a obtained from the dial as the
So now they change the
and the
material
hardness number that is
to mild steel.
suffixed.
So they have to change the load to 150 as for the hard material, and the same procedure of initial loading. Then you have to see for the second scale, brass scale, the Rockwell C scale for the measurements.
Reading on the right side. So it is it is actually cone indenter is used as the kept in position.
This is the attachment Allen key by which you can remove the attachment.
Load should be changed into 150. Whenever
Yeah, hard material 150.
load should be 150 kilo.
So this is mild steel hard material.
It is so that cone indenter. If you are using cone indenter,
After testing,
the
you can
hardness number should follow
lose it and take
by
the specimen out.
hardness testing. Get the cylindrical piece set up, then
Yeah, so this is in short, very short video on the Rockwell. I have just shown only the important points. For details, you can see the video. Then okay, after that. So back to the presentation. So for this Rockwell, you will get the hardness value directly from the dial and report the value. Next one is the Brinell hardness test. And for this one, the aim is to determine the hardness number of the given metallic specimen by Brinell test. And we need the Brinell hardness testing machine. And we will use here only the steel ball indenter of 2 diameters, say 5 mm and 2.5 mm. And we can test different materials like mild steel, cast iron, brass, gunmetal, aluminum. And here we uses the traveling microscope. So this microscope is used to measure the diameter of the indentation. That is, after testing, there will be a indentation or marking on the surface of the material. We need to measure that diameter of the marking or the indentation for finding the Brinell hardness test. So the testing machine looks like very similar to the Rockwell testing machine. The platforms, the loading arrangements, everything is same. As we know, the dial is not required, since the more features are not available in dial, because we are going to calculate it manually, the Brinell hardness value. So regarding the different specifications for the Brinell hardness test, dimensions, overall weight, all the things are listed here. And yeah, so this is about the loading balance. So one difference with the Rockwell is that in the Rockwell we can directly use the load selector for 100 and shifting between 100 and 150. In the case of the Brinell hardness testing machine available in our lab, we need to place the load on this attachment. So we have to add for 1,000 kilogram force, we need to put 500, 250, 250. So total 1,000 arrangement in a in this lever mode, so that by applying a 1,000 here, by the moment or coupled reaction, 1,000 is acting at this point. So regarding the dial, okay, so after the test in the similar procedure, we have the indentations on the surface of the specimen like this, and we need to measure the diameter of this indentation. That is from like in a way from the here to here, measure of diameter. We use a traveling telescope. So by this we will place the material on the platform. So by this arrangement, we will initially put the left extreme of the indentation on a crosshair. Then we will rotate this arrangement, and so that we can measure the total diameter of the indentation. From this diameter, we will find the depth of indentation by using the formula. So this will be the table of observations, material specimen, diameter of the indenter, then the load applied, diameter D1, D2, and then the average of the diameter and the Brinell hardness value. So the calculation is HB. Brinell hardness is given by 2p divided by pi d into d minus root of d square minus small d square. In this, p is the total load applied on the specimen, and d is the diameter of the indentation. That is the attachment used to make marking on the material, and d is the diameter of the indentation. So this is the explanation of the relative terms. P is the applied load on the material, d is the diameter of the indentation, and this d is the diameter of the marking on the surface of the material, and h is the depth of indentation. So our observation table will look like this. For brass, aluminum, and mild steel, there's a table showing different load values for different materials. For brass, we will go for 1,500 kilogram, and we have the aluminum 1,000, and mild steel, very hard material, 3,000. And in the lab experiment, we used will use the diameter of the indenter 10 mm, 10, 10, 10 for all the material, and the diameter of the indentation, which is measured by the traveling microscope, are listed here. So 3 tests were performed on brass. So we will get correspondingly 2 values taken with the microscope, and we'll take the average value. And the Brinell hardness value is described as like this. So suppose you are getting, after calculating HB, we are getting 160. It is the 160 HBS 10 by 3000 by 15. This means that a Brinell hardness value of 160 is determined with a steel ball of 10 mm diameter, as you see here, 10 mm diameter, and with a test force of 3000 kilograms. So this corresponds to this mild steel, 3000 kilogram, and it is applied for 15 seconds. So how much time it is applied, the load, static load, it will be the last number. So clearly 160 is the hardness value, 10 is diameter of the indenter, load, and time for the time of application. Okay, so we have the corresponding explanations here. 160, what is 10, 2015, but we have discussed already. Okay, regarding the video of the Brinell.
This is a
I hope the
Brinell
video is clear
hardness
to
testing
you.
machine.
So this is the
This
Brinell
machine is
testing
used
machine.
to find out the hardness of the different material. Here in the
And these are
laminate
the three
we are using
materials, one aluminum, one brass, and one is the mild steel.
some of light materials like
So he is placing the
aluminium
aluminum,
and medium hardness material like this is copper, brass, something like
this is
that,
brass,
and
and
the
this
heavy
is the
material like
mild steel
MS.
specimen.
These are using in the lab, and this is the apparatus. And the test
So
procedure
just
is
place the aluminum specimen.
the forces applied for
And in
material
the similar arrangement, we can lift this platform. So here the indenter is placed.
is like light material, medium material, and the hard material. We are using 100 system is there.
This was the loading arrangement I was telling.
There is a defaulted load that represent 500 when 500 kilogram force. So represent 250
And
kilogram force.
adding load to make it 1000.
500 here, 250 here.
For aluminum it is
Again, add
1000,
one
and
more.
for brass it was
250
1500, I
kilogram,
guess.
and that
So
is
he's adding
a
the load.
particular model of forces because here 100 kilogram force.
So the load is selected, and now he will tight the specimen.
This 10 mm it is, and this plate. It is loading condition and unload condition.
So
Now
you
it
have
is
the
unload
lever
condition.
to lock and unlock the load.
And the mission is the loading condition is coming to this plate. When we load this, and after that we can see, and after that and we go to the calculation, we can test a specimen. This is the on switch.
You also should be careful so that the previous indentation is not there. Like means the new location should be such that there should be any marking on the surface. So that is minimum 2.5 times the diameter distance from the previous indentation. Is tightening the
Just the indentation point is just touching or seating loading. Raise this platform. This large
so here also an
scale
inner
as
needle
well as
is
the
there
small scale
for
is
initial loading.
needle is changing, pointing the red spot. Then we load the secondary load or the actual load. 100. Then the indentation process is going, and needle represent the penetration is going on. When the penetration is complete in seconds, then we can count the number 1, 2, 3, 10, 11, 12. This is
This
a
was
traveling
the
microscope.
traveling
This is
microscope,
traveling, you can see
which is used to measure the diameter of the
This is the
specimen.
main scale, and this is the vernier scale.
And this is
And
the
this is
arrangement
traveling.
to move
Traveling
the
means this
microscope.
microscope is moving to and fro. This microscope is moving to and fro. We are setting the main scale as a 0.
Just like the measurement of the vernier scale
0.
for getting
Here
the
it is
diameter
also
of
0.
the
This one is also 0.
indentation.
And main scale is 0. Take the diameter of this indentation.
So through this point you can view
Both
the
direction,
indentation
X
in a large
direction and
scale,
Y direction,
and
the
you will
maximum diameter.
first you will
The mean
place
diameter
the
is
left crosser
original
on the
diameter of
left
this
point,
indentation.
and then you will move
After
it
you
on
got
to
the diameter,
next point and to
you
measure
can
the
a
diameter
simple
of the
calculation, and you get the
specimen or the
Brinell hardness
indentation.
value of this.
So by knowing the value of diameter, you can use the equations to find the Brinell hardness value. And the last experiment, it is the Vickers hardness test. So we have this experiment set up also in our lab. This is something like a digital way of taking the measurements, and the aim is to determine the Vickers hardness number HV for a given metallic specimen, and we need the Vickers hardness testing machine, and we use a single indenter. It is a pyramidal diamond indenter of a square base with a vertex angle of 136 degree, and we can use for different materials like mild steel, cast iron, brass, gunmetal, and the aluminum. This is how it looks like, the Vickers hardness testing machine. It's a compact one compared to the previous two machines, and you have a digital scale here for the measurements. So the platform is similar to the previous one like Rockwell and Brinell, but this scale is something digital scale. And you can see a closer view here. This is the platform on which the material is placed. And on this indenter point, you have two attachments. One is the this one. It is pyramidal diamond indenter, which is seen here. And the next one is the microscope. So this telescope is attached to the machine itself. So you can directly take the readings by placing the material on this platform. You don't want to shift it to a new point. So you can rotate this one by using this lever. Once you rotate this one, it will change from the indenter to telescope and vice versa. So this is the indenter is placed above the material, and you can rotate it for the telescope also. It's a digital scale. And now here you can see that the lever is rotated so that the telescope is coming directly on the sample. So here also some standard loads are there for different materials. It's like for cast iron it is 30, for mild steel 30, and brass, gunmetal, and the aluminum it is 10, 10, 10. So you can select the load here on the right side of this machine. And the procedure is almost similar to the previous one of like the testing. And for the Vickers hardness test value, HV is equal to applied load by the area of intonation is given by 2f sine theta by 2 divided by d square. And it is expressed, suppose the value is 10, this is called as 10 HV 30 by 5, which means that 10 HV is the Vickers hardness value, and it is for a load of 30. That is, it may be a cast iron or mild steel, and it is applied for a 5 seconds. This is how we will report the value of the Vickers hardness. So as we know, the value of theta is a constant value of this attachment. This is a vertex angle of 136 degree. So directly the calculation is 2p sine 136 by 2 in degrees by d square. So we know the value of load to be applied based on the specimen type, and this angle is constant as I told, and d is the diameter of the indentation, which can be measured using this telescope directly. So the values are reported like this. For material like tool steel, the load to be applied is 30, and you have to measure the diameter d1 and d2 from the using the microscope or telescope which is attached on the Vickers hardness testing machine. So I will just show the video. So the last one is Vickers hardness test. So you can see the different specifications for the testing machine, like the test load 5, 10, 20 it ranges, and test height. Regarding the least count of the telescope attached to the apparatus, and the weight and other such things. This is the digital scale. This available on the Vickers test. So this video is having a length of 30 minutes, which explains clearly the test. You can go to this video. You're having a switch arrangement here to light this one and to start the experiment. Just switch it on. This light will. Then after that, you will place the material on the platform. And yeah, this. Okay. So this is the. So I think I totally missed this. This is the indenter, and this is the microscope, because you have some scale readings on this attachment. So that in that way you can identify between the two attachments. So this is the telescope, and this is the indenter. Sorry for that. Yeah, so after switching, after like giving the power input to the biggest hardness testing machine, you have to put this one on to start the machine. So the light is blinking, and that will glow, and we have this shift of attachments if required. And there will be a start button for loading, and after the loading it will automatically cut.
Excuse me, sir.
Video visible for you?
Please do watch the video in slow mode so that you can understand everything in very clear way. So in this test, this is the material to be tested, this ring-like material. Yeah, and but this is using this lever, they are changing the telescope to the indentation or indenter.
സർ സ്ക്രീൻ പ്രസന്റ് ചെയ്തിട്ടില്ല.
And you can see so many markings on this one. So as you completed the survey classes of theodolite and theodolite, so you can know how to take the vernier readings. Similarly, you can take the readings from this one. And through this, you can also see the markings on the surface of the material. Actually, the reason why they place the telescope now is that they can see through this digital scale whether there is an indentation on that point. So if it is there, they can make a shift, and then you can turn it and make the, indenter to come over the surface of the material. Yeah, once you located that, yeah, now they fixed that point, and now they are changed. They have changed to the indenter mode.
Excuse me, sir.
Jiggle. I think he cannot hear us. Jiggle. You please chat.
Hello.
Sir, ഞങ്ങൾ പറയുന്നത് കേൾക്കുന്നുണ്ടോ sir?
Hello.
We use the same procedure to program this part. We select New Program and New Graphic. We know that the width is 1,000 millimeters and the thickness is 2 millimeters. The resistance of the material to bend is 45 kilos per square millimeter.
Hello, can you hear me?
Same punch
Hello?
as in the previous parts, because the minimum distance between folds is still small. .50 millimeters. In the cursor window, we press the down arrow to indicate.
Hello.
Hello, sir.
എന്താ ആ വീഡിയോ കണ്ടില്ല വിക്കേഴ്സിന്റെ?
ഇല്ല sir. Sir present ചെയ്തിരുന്നു. Present ചെയ്യുന്നുണ്ടായിരുന്നില്ല. ഞങ്ങൾ പറയുന്നത് സാറിന് കേൾക്കുന്നുണ്ടായിരുന്നില്ല.
Okay. I was video sound off ചെയ്തപ്പോൾ ഒരു ട്രബിൾ വന്നതാണ്. Okay, I think you can watch the video later for a better understanding. So ഒരു മിനിറ്റ്, ഞാൻ ജസ്റ്റ് പറ്റണമെന്ന് ഓടിച്ചെന്ന് കാണിക്കാം. ഇപ്പോ വീഡിയോ സ്ക്രീൻ കാണുന്നില്ലേ? ഹലോ.
Yes, sir.
ഇവിടെ വെച്ചല്ലേ സ്റ്റക്കായി പോയത്? വീഡിയോ അല്ലേ സ്റ്റക്കായി പോയിരുന്നു നേരത്തെ? ഹലോ. ഹലോ.
സർ വീഡിയോ മാത്രല്ല സാറിന്റെ ഓഡിയോയും എല്ലാതും കട്ടായി പോയിട്ടുണ്ടായിരുന്നു.
ഹലോ സോറി. ഹലോ.
ഹലോ സർ.
കാർത്തിക്, എവിടെ വെച്ചാണ് സ്റ്റോപ്പ് ആയി പോയത്?
സർ കുറെ മുമ്പ് ഒരു വീഡിയോ സർ കാണിക്കണ്ടായിരുന്നു, പക്ഷെ
അതായത് ലാസ്റ്റ് വീഡിയോ വിക്കേഴ്സ് ഹാർഡ്നെസ് ടെസ്റ്റിന്റെ വീഡിയോ കണ്ടില്ല അല്ലെ?
ഇല്ല ഇല്ലില്ല. വിക്കസ് ഹാർഡ്നസ് ഇല്ല.
അവിടെ മുതൽ സ്റ്റാർട്ട് ചെയ്യാം. ഒന്നുകൂടെ ജസ്റ്റ് ഒന്ന് ഷോർട്ടിൽ പറഞ്ഞുതരാം. ഇപ്പൊ സ്ക്രീൻ കാണുന്നുണ്ടോ?
കാണാണ്ട്.
ഇപ്പഴും കാണുന്നില്ലേ? വീഡിയോ കാണുന്നില്ലേ? പ്ലേ ആവുന്നില്ലേ?
കാണാണ്ട്. പ്ലേ ആവുന്നുണ്ട്.
ഓക്കെ ഓക്കെ. വോയിസ് ഒന്ന് കുറയ്ക്കാം. സോ ഈ വീഡിയോ ഓൾമോസ്റ്റ് ഒരു 20 minutes ഉണ്ട്. സോ അത് ക്ലിയർലി എക്സ്പ്ലെയിൻഡ് ആണ്. ആൻഡ് ഇമ്പോർട്ടൻറ്റ് പോയിന്റ്സ് മാത്രം ഒന്ന് ജസ്റ്റ് ഷോ. So we have different test loads that can be applied on the specimen, and other details of the machines are given here. It includes the least count of the telescope available. And in short, you have a switch here for the power supply, and this is the Vickers testing apparatus. This is the digital scale I was telling about, and on the this is the platform on which we are placing the material, and you have two attachments here. One is a traveling telescope as well as the indenter, and this is actually the indenter which is having a sharp edge, and this is the traveling telescope.
And on this, you can see this is the loading area. This is actually a platform over which the specimen is mounted, and here it is coming with the it is consisting of the two.
So this is the indenter and telescope.
Vertical tubes or cylinders you can see, and the first one is just like a telescope for viewing the specimen as well as the indentation made on that one. And then the second one, this is actually the indenter. These are actually kept at 90 degrees with each other, so that by rotating this base plate on which these two are fixed, we can bring the indenter or the telescope over the.
Sir, here in the video, audio also of this video.
Yes, yes.
Yes. Okay. Yeah. Okay.
On this machine, you can see some switch provided on the side. This is actually the switch which is controlling the light that is available on the loading area. So, by switching this one, you can put the light on, and then on the side of this
This is the power switch, and the previous one was a light switch.
on the machine. So first,
I'm just making fast forward. So
on the front side of the machine, you can view this one. There are two switches, one yellow switch as well as one green switch available. And this green switch is the starting switch. That is, if you push the blue button, the machine will get started and automatically loading will take place on the specimen that is kept on the loading platform. And after the decided or tuned time lapse, that is 5 seconds, 6 seconds, 10 seconds, etc. After you put on the loading, after completing that time lapse, so automatically the loading will be cut and the will be released. And while cutting the load, this particular blue light will come on. Then for conducting the experiment, first you also switch on the light on the loading area. Then
this is how you change the attachments, shifting from telescope to the indenter.
As the height available is not sufficient, we are keeping another piece of the mileage in our diagram. So it should be like this, so that the space in between the loading platform and the indenter will be minimized.
So this is a part of the sub platform. This is only the material to be tested.
So that is inserted. Now the telescope is coming above the specimen, so that through the telescope we can view and image appearing on the machine through this particular slit. The light is coming in. And we also view if there are some indentations already made on the specimen, can it is visible or not. And if it is visible, we also relocate it where there is no indentation coming on the surface.
So making it fast forward, so we can see the image of the telescope through this window, and we can arrange the material accordingly. And after identifying the proper location to make the marking, you can shift from the telescope to indenter mode.
There is no indentation coming immediately below the telescope.
And these are the telescope readings.
Indenter is coming immediately above the specimen. After that, you by rotating this loading platform with the lever provided at the bottom, you keep when goes up. Here this step has 6 seconds. Lowering the platform.
So this telescope can be used for seeing the surface of the material to properly place the indenter, and after locating that, you can shift to the indenter mode, apply the load onto the material through the indenter. Then after that, again change to telescope mode to find the diameter of the indentation through this digital scale, and using the diameter of the indentation by using the equation given for the Vickers hardness test, you can find the Vickers hardness Vickers hardness value in a very simple way.
After that, the position of the telescope may be brought immediately above the specimen on right orbit. At the middle, one graduation is again subdivided into 10 divisions. So that 10 divisions, that one shown on this, so you can see that while rotating this is 0, 0.
So please do watch the video in very slow mode, so to understand the readings in a clear way.
The provider on the outer side, the lines are coming at the ends of one diagonal. So in between here,
the markings like for the vernier.
So here it is 5, and if you use the then they will come here D in millimeter. So this is the experimental measurement you have to measuring the diagonal.
So after that in video he is explaining regarding the diameter measurement based on the indentation, and this is the corresponding angle of the indenter, and we are measuring the diameter like this, as we have a square type indentation on the surface, and this average will be taken and we'll apply in the equation to find the Vickers hardness value. So after getting the value of the diameter of the indentation using that traveling telescope, you can apply to this equation to find the Vickers hardness value, which will be the aim of the experiment. So we discussed today regarding the 3 tests, the Rockwell, the initial one, which is having the B scale and the C scale readings directly taken to find the Rockwell hardness value. then we jump to the Brinell hardness test, where you will use a traveling telescope to find the diameter, and you have the set of equations to find the Brinell hardness value. And the last one is a digital Vickers hardness testing machine, by which you will measure the diameter of the indentation using that attached telescope. And then you can find the hardness value by using the equation. So all these are hardness values which are expressed in different scales: the Rockwell, Brinell, and the Vickers hardness test. So hope the basic things about this hardness lab is clear to you. And please do watch the video, if possible, just immediately after this session, so that you can understand the experiment in a better way. So any doubts? Okay, I will just note the attendance. 1, 2, 3, 4 is absent. Roll number 4. 5, 6, 7, 8, 9, 10. 11 is absent. 12, 13, 14, 15, 16, 17 is absent.
Sir, 17 ഉണ്ടായിരുന്നു. ടൈം കഴിഞ്ഞുകൊണ്ട് ലെഫ്റ്റ് ആയപ്പോൾ പിന്നെ റീജോയിൻ ചെയ്യാൻ പറ്റുന്നില്ല.
ഓക്കെ, 17 ഉണ്ടായിരുന്നു. ഓക്കെ, ഞാനത് മാർക്ക് ചെയ്യാം. 16, 17 ഉണ്ട്, 18, 19 is absent. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. 37 is absent. 37 absent. 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 53, 54 is absent. 55, 56, 57, 58, 59, 60, 61, 63, 64, 65, 67, 68 is absent. So the absentees are 4, 11, 16, 19, 37, 54, and 68. So ma'am, any announcements to make? Subeda ma'am?
No, nothing.
So I told them, so we covered 2 experiments today. The Brinell is a single experiment, and we have we took the Rockwell as well as the Vickers test. So we completed 8th and 9th experiments in this class. So next class we will cover the test on springs, the 10th and 11th experiment, and the 12th experiment will be taken directly in the lab. Okay, so that's all for today.
സർ,
Yeah, പറഞ്ഞോളൂ.
ലാബ് സെഷൻസിന്റെ ഷെഡ്യൂൾ അങ്ങനെ എന്തെങ്കിലും ഒന്നും
ക്ലിയറായിട്ട് പറയും. ഞാൻ ഇത് പറയുന്നത് മുന്നേ ഉള്ള ആ നോട്ടിഫിക്കേഷന്റെ ബേസിലാണ് പറയുന്നത്. ലാസ്റ്റ് ഒരു K2ന്റെ വന്നിരുന്നല്ലോ, അത് എന്തെങ്കിലും ചേഞ്ചസ് ഉണ്ടെങ്കിൽ ഒരു സർക്കുലർ അഗെയിൻ ഉണ്ടാകും.
സർ, കഴിഞ്ഞ തവണത്തെ പോലെ ബാച്ചസ് ആയിട്ടാണോ വരുന്നത്, എല്ലാരും കൂടെ ഒന്നിച്ചാണോ?
അത് മിക്കവാറും ഡിസൈഡ് ചെയ്യുന്നത് ട്യൂട്ടറും കൂടി ഇൻവോൾവ് ആയിരിക്കും. അപ്പൊ ഞങ്ങളത് ഫൈനലൈസ് ചെയ്തിട്ടില്ല. എന്തെങ്കിലും റിവൈസ്ഡ് സർക്കുലർ വരുവാണെങ്കിൽ അത് ആലോചിച്ചിട്ടായിരിക്കും ഡിസൈഡ് ചെയ്യുക.
ഓക്കെ സർ.
So we will stop for today. Please ipo thanne watch cheya video so that it'll be good. Sheri anna, thank you.
Okay, thank you.
Thank you, sir. Thank you, ma'am.
Thank you, sir.
Thank you, sir.